All right, in this video, I'm going to show you a few kind of ways to think about some key features of a parabola. Specifically, how do you find the vertex, the zeros, the domain, and the range, and what are some patterns that we can notice? I also, one of my goals for you is that you can represent a parabola using both a table and a graph. So if I give you an equation, I want you to be able to give me a table and a graph. And if you can do the table, the graph is easy because it's just plot the points. So we're starting with a fairly straightforward parabola. I know it's a parabola because there's an x squared term. It's that x squared term that makes it kind of dominates as x gets really, really big. Like if it was 100 squared, for example, 100 squared minus 9, that 9 is not really, that doesn't matter at all. It's that x term that's really going to drive kind of the properties of this function. It is a function. I've written it in function notation. You will also see parabolas not in function notation. So y equals x squared minus 9, same exact function, same exact behavior. It's the same exact thing. It's just not written in function notation. Okay, so table. This is if my input is -4. So I'm going to show my work for a couple of these and then just bust out the arithmetic. So this first one, -4, f of -4 equals -4 squared minus 9. Now I put that -4 in parentheses because the value of x is -4. So it's the -4 that I'm squaring. I'm doing -4 multiplied by itself. Putting parentheses around it reminds me that I need to go do -4 times -4. Negative times a negative is a positive. So it'll be 16 minus 9, and 16 minus 9 is 5. So f of -4 is 5. Doing the next one, f of -3 is going to be -3 squared minus 9. -3 times -3 is 9. 9 minus 9 is 0. F of -2 is going to be -2 squared minus 9, which is 4 minus 9, which is -5, I believe. F of -1 is going to be -1 squared minus 9. Oops, minus 9, which is 1 minus 9, which is -8. -8. And then I'm running out of space. F of 0 is going to be 0 squared minus 9. I can put parentheses there if I want to. I don't really need to because I don't need to remind myself that I'm squaring a negative. 0 times 0 is 0. Minus 9 is going to be -9. And then from here, f of 1 is going to be the same as f of -1 because I'm going to do, check this out. So f of 1 is going to be 1 squared minus 9, which is 1 minus 9, which is -8. F of -2 is still going to be 4 minus 9, which is going to be -5. F of -3 is going to be 3 squared, which is 9 minus 9, which is 0. And then f of -4 is going to be this -4 squared has the same value as +4 squared. So 16 minus 9, this is going to be 5. So I've done the table. Some key features in the table. So this number right here, when x is 0, y is -9, or that value, the output function is -9, this is going to be our vertex because you can see it goes 5, 0, -5, -8, -9, and now it turns around and starts going back up again. So the vertex is going to be right here at 0, -9. And then the zeros are going to be where the output is 0. And we're going to see that on the graph here too in a second. Okay. Parabolas never have more than 2 zeros. Sometimes they can have 1 0, and sometimes they don't have any zeros or not any real zeros, but they can't ever have more than 2. That's the maximum. They can have 2, 1, or 0 zeros. Okay, so looking at the graph, -4, -1, -2, -1, -2, -3. I should have made my graph a little further. -4 is at 5. 1, 2, 3, 4. Oops. Well, there you go. And then -3 is at 0. And then -2 is at -5. So -1, -2, -3, -4. -5 is right here. -1 is -8, so 5, 6, 7, 8 is right here. And then right there. And then it's symmetrical. 1, 2, 3. And so 3 is 0. And then up here at 5. 1, 2, 3, 4. And you'll get better at sketching parabolas the more you practice them. And remember, it's a curved line. It's not really a straight line between the different points. It's a curved line. Okay, so here, right here, we can see the bottom, the smallest point is this vertex. And that point is at 0, -9. So the vertex for this function is 0, -9. And we can see here a 0. This is the x value. This is the y value. Y axis, x. Okay. So a 0 is going to be essentially our horizontal intercepts or our zeros, because those are the places where the output value is 0. So our zeros, our input is -3 or +3. You can also write this way, positive or -3 if you wanted to combine it. It's the same thing. Domain. Domain is what are the possible x values. This line, this curve continues on indefinitely. There's no context here to limit what values of x would make sense. So the domain is really all real values. Any number. X can be any number. But the range here, the y value, it goes up forever, but it can never be smaller than -9, but it could be -9. So y has to be greater than or equal to -9. Yeah. The only other thing that I think is worth noting is you can see here, there's an axis of symmetry. And all that means is that the shape of this side of the parabola is symmetrical to the shape of this side of the parabola. So if you folded it, if we folded this paper along this axis of symmetry, and the name of this axis of symmetry is x = 0 is the name of this. So like when x = 0, if this, that's the line here. Yeah. And knowing that, like using the axis of symmetry can be really helpful sometimes. You can also see it, like you see the symmetrical behavior in the table where it goes 5, 0, -5, -8, -9, and then it goes back up, -8, -5, 0, 5. We see that symmetry in the table too. Great. Okay. Well, that's all I have to say about key features of parabolas. Have a great day and stuff.